So welcome to our last lecture, and today I'll be talking about the technologies that drive our age. Now there's some housekeeping we have to take care of first. You don't have to do a presentation on your paper. You don't have to do any postings. Basically, I'm just going to simplify it for you. There's only two things left, and then you're done with this course. And that's that you have to get your quizzes in. That's by next Friday. And the final paper, which is the Sunday following that. So in terms of technologies, we're going to define what they are, tell you how they work, what are the implications, give you some examples, and what the future holds. And what our age is defined by is pervasive computing, wireless mesh, biotech, machine learning, nanotechnology, 3D printing, robotics, and add all of this up, and it's what we refer to as super tech. Now, what's the criteria of calling something a super technology? And that's that it has to have intelligence, meaning the tech can act on the environment. It's got to be able to fit with people, so it's easy to use. It has to be able to be widespread enough that it can go everywhere. So it just can't be like some nerd project. It has to be able to be producible. And finally, what part of our world does it impact? So the idea of pervasive computing is that we have microprocessors everywhere. And because we have microprocessors everywhere, it's this idea we've gotten away from hubs and spokes. It's all about now distributed networks. So you don't have to store all your data in like a central data farm. You could store it at the device itself or put it in different places. And so there's a ubiquity to this technology, and the barriers have brought down what we traditionally thought of the ways to treat our networks and data. And it transforms us to unlock new abilities. And on the horizon, what the future is showing is that we're going to have smart cities, microgrids, and telemedicine. Wireless mesh networks are, we assume that we need a router for to have a connection, and we don't. And the reason why is because devices can talk to each other. As long as you've got one of them in your network that can connect to a router and the internet, then you can have an entire mesh network. And they're actually working on it for cities because it's not practical to have so many routers in so many locations. So they're trying to make a new kind of web network. WasabiNet, I believe, is the city of St. Louis trying to do that. It's lower cost infrastructure. There are global initiatives all over the country, all over the world right now, trying to do this. And it's impacting several industries such as auto and healthcare. Biotech. What drives biotech is basically genetic engineering, cell technology, and also digital technologies. The idea is they want to create new technologies that are preventative instead of reactive. And preventative means your body senses like the cells are starting to form to give you leukemia or something like that. And so you kill those right away. So go after the illness before it really becomes an illness. And the way cells work is they actually look at the protein shape of something else. And if it identifies that it's something that it needs to attack, then it does go and attack. My brother is actually a biochemist. And when AIDS first came out, he just said, we're not going to come up with a vaccine anytime soon. And the reason why is the AIDS virus mutates. And because it mutates, there's no single protein structure that it can be attracted to. And that's a problem. Biologics is the major drugs of our day, Humira, Enbrel, a lot of drugs like this. And what they're based on is biological material. And they can reproduce it as a serum. So people take these as IVs. Gene therapy, they're looking at how can they make drugs specifically targeted towards your genetic structure. Biomarkers, which is about food, IDing plants. And emergent devices are those that are always with you. So implants or wearables are emergent devices. 3D printing, the big problem with 3D printing is it's great for customization, but if you know you want to make 1 million or 10 million of something, 3D printing tends to fall short because of the other technologies, because those are designed for large scale, like injection molding. If any of you ever watch a plastics machine, it's just amazing. I mean, they turn it on and things just keep spitting out. But what's happening now is they're finding other applications for 3D printing, such as ceramics. They've made pills using 3D printing. The idea is this: what requires customization? And so the thinking behind drugs is that we're all different. Everybody's got a different body and everything else. So why not make a drug specifically for you? They keep improving the technology. They want to go down to the molecular level. I believe right now their precision is like 10th micron, and they want to do better than that. Vacuum systems can go down to 0.03 microns. It's cheap. 3D printing is cheap. I thought about buying one many times, but then I thought, oh, what the heck am I going to do with it? And it's not that I can't do the CAD and stuff. I just don't have the time. But the problem with 3D printing will always be scale. Machine learning is driven by the cloud, big data, and AI. Machine learning is a subset of AI. And for those of you who don't know the actually, I gave you the definition of machine learning in the last lecture, so I don't have to go over it. But analytics, operational, strategic, and interpretive, meaning, do we want it to monitor things, or do we want it to make decisions? Nanotechnology, these are considered to be the materials and devices less than 1,000 angstroms. When you talk about these kind of systems, they are driven by three things: the chemistry, the process, and the tool they use. All three play a role in it. Here's a profile of what a chip looks like. The width of those long pillars in the middle, those are actually called vias, and they're about 1 micron wide if you need to get some kind of perspective. Now, if you look at this diagram and see where it says metal, metal, this is the way a chip connects itself. That metal is actually the wires that connects different parts on a chip. And they're actually up to like 15 layers. Now, the tough thing is, how do you isolate those metal layers with something that can first of all planarize? Because if you stack things on top of each other, they start to become uneven. And that material, actually, one of the early materials, Dr. Cho was on that team that did that. Primarily, nanotech has been around for a long, long time. It's been around since the 60s. They just gave it a new name to get buzz and interest. But what they do now more is, before they were used for scientific stuff and advanced stuff, and now what they want to use it for is everyday commercial products. Lululemon, for example, the people who make yoga clothing, their polymers are actually embedded with silver particles, which are antimicrobial. They're also anti-static. And I never knew about this. A student told me about this in a presentation for a class. And I said, wait, that technology was not created by Lululemon. That technology's been around for a while. And I should know, because that technology was invented by a DuPont chemist named Dr. Thomas Cho, my father. Anyway, the drug patch, UCLA is renowned for that, those coatings. And also Under Armour is constantly trying to improve its clothing line. And they actually have a bioceramic coating to try to reflect heat off of their shirts. So nanotechnology is just another part in a long chain of inventions. And what's driven our age is actually, first and foremost, invention's been driven by by materials. The semiconductor business would have never gotten started until the theory was around for 30 years. Nobody could build a good enough semiconductor. And then somebody figured out how to make silicon and how to do it cheaply. Subsequently, the polymers and everything else that have been developed for these industries have defined our age, because these are enabling technologies. They allow it to happen. The next big step for these types of technologies is, can we bend them? Can we make them in simple form that form around us? And The big challenge for nanotech is to be clean. That they don't want these particles poisoning people or becoming a health hazard, and people are really concerned about that in our world. Robotics, the reason why robotics has reached the level it has today and was introduced is just because they can meet tight tolerances, that they can perform to the level that we want. They're flexible. You can reprogram them. They can do different things. They can complete tasks quickly. And now we're adding intelligence to the robots. And so they learn how to apply information. Robotics is a field that's actually an interdisciplinary field. You need to know electrical engineering, you need to know mechanical engineering, and you need to know software. And the intersection of all that is robotics. And so, what are robotics good for? Well, they're good for repetitive tasks. They're good for high-risk tasks that you'll want to send people in. If you need high performance, meaning people just can't go fast enough, like canning, that's what robotics are good for. And also in terms of capability, are they creating new spaces that humans can't perform into? And the big challenge is robotics is, first of all, software. You need a lot of code in order to do something. And the cost of this development, is it worth it? And finally, the human interface. Can you make this work with people suitably? There are a couple of myths. The picture on the left is from a movie, Fantastic Voyage, that we're going to shrink down submarines and have them fly through our veins, or we're going to make little microbugs. Now, the thing about people, they get enthusiastic about technology and start giving you the whole Star Trek version of the world, but there's more pragmatic and economic issues you have to deal with. And that's that in these systems, where's the code going to come from? How are you going to power the battery? Your system limited on what you can do on certain of these things. We talked about last time the digital technologies that define our age. And so now we're going to talk about some of those technologies specifically, meaning IoT, blockchain, cybersecurity, and silicon technology. And we'll do that in the next video.